section 8.3 with this very last problem. That's part B, problem number 35. Okay, at the end of class, we were doing a outlier box plot for a data set. And we were to use the circle or dot for any outliers there. And I did part A last time. So now we'll just go ahead and do part B. And in this case here, we're going to, we have this data set for part B. We'll go through all the numbers there. But in this case, we're going to draw an outlier box plot for that data set and use the circle for any outliers. And I do have those numbers up there on the board. So let me go and do the stop share. Okay. All right, so basically what we're going to be finding, we need to know what the mean is, and what Q1 is, and Q2, Q3, and the max. Okay. Now we did talk about any values that were unusually low would be an outlier, or any values that are unusually high would also be an outlier. Now we did one where one of the values was unusually high. And I think that number was 360. Yeah. And we did you had to draw a dot there for that outlier. And the 240 had to be the maximum for that box plot when we constructed it. All right, so in this case here, we'll start by finding what Q1, Q2, and Q3 are. And then we find the interquartile range. And then we use Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. And then use that to do the min, the max, and find Q1, Q2, and Q3. Let's do Q1 first. All right, in this case, if you recall, the first quartile is the 25th percentile. Okay. So to find the position of the number that's in the 25th percentile, we have to do I is equal to P over 100 times N. And our P is 25, that's divided by 100 times N. In this case, it's 2, 4, 6, 8, 10, 12, 14, 16. So we got 25 divided by 100 times 16. So when we do 25 divided by 100 times 16, that's going to be what, 4? And it ended up being an even number. So that means we need to look for the fourth digit number and the fifth number and take the average of the two. So what is the fourth number in this sorted data set? 82. And by the way, I do need to mention that this data set has to be sorted before you start doing anything. And what's the fifth number? 112, 112. So 82 plus 112, 194, and 194 divided by 2, 97. So that means that Q1 is going to be 97. And now for Q2, that's of course the 50th percentile. So here we have to do I is equal to, this time P is 50 divided by 100 times 16 is 8. And again, that is a whole number. So that means we have to do the 8th number, and the 9th number, and get the average of the two. The 8th number is 1. That's the 2, 4, 6. That's 7. 119. Plus the 9th is 120 divided by 2. So 119 plus 120 is 239. And then 239 divided by 2. Okay. So here, Q2 is 119.5. And then finally Q3, well, Q3, that's the 75th percentile. So here we have to do 75 divided by 100 times 16. That'd be 12. So here we're looking for the 12th and the 13th number in this data set. And we're going to take the average of the two. Here the 12th number would be, that's 10, 11, 12. That's 125. Plus the 13th number, that's 128. That'd be 253 divided by 2, which is, okay. So that's Q3. 126.5. Okay. Next, we're going to look for the interquartile range, or IQR. Now, the interquartile range, of course, is defined, can be found by doing Q3 minus Q1. In this case, Q3 is, okay, and Q1 is 97. So we subtract 97 from 126.5, and what will we get? That'd be 29.5. Right? Now, to find our unusually low values in this data set, this is where we do Q1 minus 1.5 times the inner quartile range. And in this case, our Q1 was 97 minus 1.5 times the interquartile range of 29.5. Yeah. Yes. Mm-hmm. Yeah, 52.75. So that means if we have data values that are less than 52.75, those are considered to be outliers. So by looking at this data set up here, do we have any outliers here? 20 and 30. 67 is, yeah, okay. 67 is greater than 52.75. So these are the only two that are outliers. Okay. So I'll write this out. Outliers here are 20 and 30. Okay. And now, for the unusually high numbers, we do Q3 plus 1.5 times the interquartile range. And in this case, our Q3 was 126.5 plus 1.5 times the interquartile range of 29.5. How much? 170?
Is it 70.75?
No, it can't be.
Oh, no.
Can't be.
I'm sorry, I gotta keep that.
Okay.
Okay.
Now this is what I came up with. Yeah.
So wait a minute, let's see what I mean.
126.5.
Okay, I just put 26. That's what it was.
Okay.
Is that plus 1?
Plus 1.5 times 29.5.
I got it.
Okay. Now, are there any data values here that are greater than 170.75?
No.
No. So the only outliers are 20 and 30, which means the minimum, if these two are outliers, then that means that 67 has to be the minimum. And of course, for the maximum, that'd be 142. Okay. Any questions about what I just did here? Okay. So I have my 5-number summary. All I need to do this is draw the box plot for this. Well, the 20 and the 30 are the outliers.
Okay, then the next number.
Yeah, the next number.
Okay.
Any other questions? Okay, we'll start with 0. I'm gonna do these by 20, and then 40, 60, 80, 100, 120, 140, and 160. So this is where the box, this is what the box plot looks like. I know that my outliers are 20 and 30. So at 20, I'm gonna draw a dot there to indicate that what my outliers are, and then 30 is halfway between 20 and 40. So another dot goes there. The minimum is 67. So let's say 67 would be about right here. So that's gonna be a small vertical line there. And then 97 is Q1. Let's see, that's close to 100. So that's gonna be the longer vertical line that starts the box. Q2 is 119.5. That's almost 120. And then 126.5 is Q3. So that's about right here. So these 3 lines here that I've drawn creates the box. And this whisker connects from the minimum to the Q1. And then the max is 142. It's a little bit past 140. That's about right here. Then we connect that line from the maximum to Q3. So this is what my outlier box plot looks like for this data set. Any questions about part B of problem number 35? Okay. So that wraps up section 8.3. And it wraps up chapter 8. Okay. So when this class is over, pretty much that homework in a website will be available for you to complete. Okay. All right. Let me